Hey everyone, I just wanted to give you guys a little bit of a introduction to linear functions. And why are we going to use linear functions? Well, because they're actually the basis for calculus. And yes, I know the thing that you learned in 7th and 8th grade is the same thing that's used in colleges and universities everywhere. Um, and also labs and the main foundation for mathematics and engineering and physics. Um, it all boils down to linear functions. So I know that you guys have worked with linear functions in the past. This is just for a stronger foundation, so we get a nice foundational skill of linear functions, so that when we actually get down to it, it won't be new. It'll be stuff that we are strong and we are comfortable with. So linear functions. We are actually going to get a more formal definition of linear functions when we work with polynomials. We'll do polynomials and piecewise after this, but just wanted to give you um, just a short lesson on what they are, why we use them, and all the different forms that they could take. So a linear function actually is I tried using the PDF um, editor with the um, tablet that I have, but if, as I recall from virtual teaching, it's not the most easy to navigate, and it glitches out a lot. So that's why I'm switching to a Promethean software, just because it's a little bit easier. But you have a linear function. It's any uh, function that takes the form ax plus by equals c, where you have a, b, and c being all real numbers. So you have a, b, and c being all real numbers, and uh, x being, of course, your x coordinate, and y being your y coordinate. And what that makes is a nice graph, a nice straight line from wherever your form is. So ax plus by equals c. Now that can, a linear function is defined by any function that takes the form of that. There's, as I said, another definition that we'll take a look at next time, but I wanted to give you guys also another look into the other types that this thing could be seen as. So we need to actually take a look at what's known as slope. And with slope, you are looking at pretty much the rate of change, or the average rate of change, you might say. So not just simply your rate of change, which we know as the variable m. And since it's the rate of change, it'll be our change in y over our change in x, which is going to be our second y minus our first y over our second x minus our first x. And as long as we keep these ones and twos the same, when you have 2 points that are in the form xy, we will be golden. So in the basic form, your slope is going to be labeled m, but regardless, it is just going to be your change in y over your change in x. So if you imagine a line such as that, we know that its slope, pretty much how much it's going up or down, is just going to be its change in y over its change in x. And you can get these 2 points because, well, this is x1, y1, and that's x2, y2. So, as I said, you have the slope being the average rate of change, and then we have also our y-intercept. I know I have this in the next part. Being where line crosses the y-axis. And I'm just going over this quickly just because you know what a y-axis is and what an x-axis is. And your y-intercept is just that point right there, known colloquially as lowercase b. So why I give you this is because there are actually different forms, and you guys know this, different forms of a line. Different equations of a line. You first have your standard form, which we know as, that was our basic ax plus by equals c. Where, as I said, a, b, and c are all real numbers. And then you have your slope-intercept form, which is probably your most known. Which takes us, well, you need a slope, you need an intercept. We know that our slope was m and our intercept was b. So you get the nice equation of y equals mx plus b. So that's a little bit of a look into y equals mx plus b. You have Desmos. I'm sure you're familiar with it. You can go to point slope form. And it's just a little tool to help us figure out, okay, here you have your y and your y-intercept, actually. So whenever x is 0, that's our y-intercept. Sorry, that's not the right form. Slope-intercept form. So I was wondering, oh, something's off. But you have your B, which is your y-intercept. So where it crosses here, it crosses -2 or crosses +2. And then your slope is how steep everything is. So higher slope is really steep, and a negative as slope close to 0 is no change, whereas a negative slope goes from up left to down right, positive down left to up right. Y equals mx plus b. So as you can see, you have slope intercept being y equals mx plus b. And then as I mistakenly clicked, you have the last form being point slope. So we have our point, x, y, and our slope, m. And the names are pretty simple, making this y minus y1 equals m x minus x1. And this is one that I want us to get really comfortable with because we'll be using it a lot later on. But these are 3 standard forms. Now, that goes to the equations. And then you have to deal with, well, parallel and perpendicular lines. So, just quickly, we'll take a look at 2 lines that are parallel. So no graph, no equations, just we're taking a look at what these lines are. So how do they relate to each other? Well, you may recall that if we figure out their slopes, are going to be equal. So we know that for parallel lines, our slopes are going to be equal. And then for perpendicular lines, this is where it gets a little bit trickier. So lines that cross at a right angle, you have, well, you notice that the slope of one, well, we know that the other one is going to be negative, but if you're to take a look at what the uh, negative is, so this does not have negative slopes, so you have to create your own. But I'll just do y equals ax c. So that's the only way that we can sort of get the other ones to show. And I'll just make this a different color. So you have your 2 equations, and in this case, a is going to be our slope. So if you take the 2 lines, and let's say our first slope is 1, and the other one is 1, well, you can say that they are perpendicular, hey. But let's make the other one 2, or 1.5. So here they're going to intersect at that point. But then we want the other to be perpendicular. So let's slide this around until we see what we can see. So we know it's going to be opposite, so let's try -1.5. So negative 1.5, are those meeting at a right angle? Not really. But let's play around with it. We know it has to be a little bit less steep. So, I mean, that's okay. And that's okay. So it's going to be between negative 6.6 and negative 0.7. Well, let's try making this a 2. And hey, those meet up at a right angle. So we have 2 and negative 0.5. Or you can also say that's going to be negative 1/2 or negative 1/2. So we know that these are going to have what are known as opposite reciprocal slopes. So slopes that are opposite reciprocal, which means that you have something in the form of, let's not use A. Let's stick with M. One equaling negative 1/m1. So you have your slope being the opposite, and the reciprocal just means 1 over that. So you have opposite reciprocal slopes for perpendicular lines. So let us take some time to do a couple of practices. So we want to write down the equation of the line that passes the 2 points. You can give your answer in point slope and slope intercept. Well, if we take a look, we want point slope and slope intercept. Both of these are asking for something with slope. So we need to find the slope between 210 and 214. Let's try that. So we need to find our slope, which is going to be our change in y over our change in x, which, if this is x1, y1, and that's x2, y2, our change is going to be 14 minus 10 over 2 minus 2. And whoa, hold up. You're getting 4 over 0, which in our case is going to be undefined. Or you could say it's going to be an infinite slope in this case. It's not always going to be the case, but it's an infinite slope, which means it'll be vertical. So, what does that mean? Well, let's try putting it into general terms. So, we have a graph that goes through 210 and 214. Well, the equation of that line is just x equals 2. Because y could be anything, but x could just be equal to 2. So honestly, we're done there. We can't put it into point slope form because there is no slope. We can't put it into slope intercept form because once again there is no slope. But that's all we can really do. So, as a little bit of extra practice, there's for you and for the extra part of the assignment, there's 6, 0, negative 1, 3, and then negative 1, negative 6, and 4, negative 6. So it'll be up to you to figure that part out. But then there are also two more questions, one of which we'll go over. So we need to find the equation of the line through 6, negative 1 and parallel to 9x plus 2y equals 1. So find the equation through that point and parallel to the line 9x plus 2y equals 1. So if we have 9x plus 2y equals 1, we know that parallel lines have the same slopes. So let's figure out what the slope is. And one of the simpler ways to do that is to get this into a form that we can recognize what's there. So let's get it into the form y equals mx plus b, or slope-intercept form. So we need to convert this into this, and that requires just some algebra to isolate y by itself. So we're going to subtract 9x on both sides, and you're left with 2y equals negative 9x plus 1. Then in order to get it by itself, you need to divide by 2. So you're left with y equaling negative 9 over 2x plus 1/2. And boom, we have our slope. Slope, of course, is, don't forget that negative out front, negative 9 over 2. But we want it to go through the points negative 6, negative 1. So if that's the case, we know what our point is, we know what our slope is, so we can simply solve the puzzle knowing that our point is going to be 6, negative 1, and our m is going to be negative 9 over 2. So we can substitute into the form y minus y1 equals m x minus x1, where y minus 1 equals negative 9 over 2 x minus 6. And then to simplify it a little further, y plus 1 equals negative 9 over 2 x minus 6. And there you go. There it is in point slope form. If you want to get into slope intercept form, well, you can do a little bit more algebra to simplify. Distribute the negative 9 over 2